Examples of elimination method where you're going to see either a no solution result or an all points on the line result. So looking at example number 1, I'm going to try to eliminate the x's. I'm just choosing that because it was first and I didn't notice anything, very special about either one of these. So I'm just going with x. And I'm just thinking in my head, I can just multiply the first equation by 2. If I do that, this would become a positive 2x, and then the positive 2x and the negative 2x will cancel. So I'm going to multiply everything in that first equation by 2. And I'm going to leave the second equation alone, copying it just the way it is. And now, as I look at my x's, they eliminate, which is what I was hoping that they would do. So let's go ahead and we're going to add the 2 equations together. This will eliminate, and then here's the weird part that happens. The y's are also going to eliminate. That was not my intention when I started the problem, but they are going to eliminate as well. So here's my equal sign. I have a 4 plus 2, which is 6 on the right-hand side. What is on the left-hand side? If the x is eliminated and the y is eliminated, they are gone. I have nothing on the left-hand side. I need to put something there. I can't just have like equals 6. So what we're going to put there is a 0. There is nothing on that left-hand side. And so because the variables have all been eliminated, and right now I have a false statement, say false statement, then my answer for this question is no solution. So when the variables all eliminate and we have a false statement, we say no solution. The key thing to this happening though was that both variables eliminated completely, vanished. So for number 2, you can kind of imagine what's about to happen. The same scenario is going to play out. All the variables will eliminate, but we are going to have a true statement at the end. Let me fix this up. That's not supposed to be, that looks like a negative for a second there. Let's say 15. So let's go ahead with number 2. And if you want to pause the video and try it, I encourage you to. Sorry about that. So I'm looking at my x's. They are not multiples of each other, 2 and 5. I'm looking at my y's. They are not multiples of each other, 8 and 20. So I'm just going to go with eliminating the x's because they're smaller numbers. I'm going to switch my numbers, 5 and 2. And I'm noticing that this would be positive 10x and positive 10x. So one of them has to become negative. I'm just going to put the negative on the 5. Why not? You would get the same answer if you put the negative on the 2. So I'm going to go ahead and distribute that and multiply this through. And I'm going to do the same thing on the second equation. And so now my intent was to eliminate the x's. That's what I was thinking ahead of time. And that definitely happens. But also the y's eliminate. Negative 40 and positive 40, that eliminates. So on the left-hand side, we have 0. And then negative 30 and positive 30, that also eliminates. So all we have left on that side is also 0. So 0 equals 0. This is a true statement. And when we have true statements, we are going to say all points on the line. Graphically, example number 2, when we graphed it, it would be the same line on top of each other. Graphically for number 1, when we graphed it, it would be 2 parallel lines that never intersect. Right? We had very similar things happen with substitution method for these, where when the variable eliminated and we had a true statement, we say all points on the line. When the variable eliminated and we had a false statement, we say no solution.